question that we are looking at over here is number of atoms. And if you have read the question, if you have not read the question, then I suggest reading this whole description first because that will help you understand the explanation. Now, the data structure that we're going to use over here is a stack. And what we will do is we will keep one counter per level of nesting, and when we open a parenthesis we start a fresh level, and when we close a parenthesis we collapse that level into the one below it and we scale it by the multiplier. So I'll explain it, what I mean by, for example, scaling it by a multiplier. So over here we have our I, so this is our current position in the string, and we will move it forward manually as we are parsing. Now n is just the length of the formula, so we know like when to stop, when is the end of a loop. And then stack, it starts with one empty counter. Now this bottom counter represents the outermost level, and by the end it will hold the totals of for the whole formula. Now we are starting with two helper functions which are basically parsers. So we start with a non-local I. So what this does, it will help, it lets the helper function modify the I from the outer function rather than making its own local copy. And now we will, we remember where we started, and then we keep advancing while we see the digits. And when we stop, at formula start until 1 is the number that we have consumed. Now the key detail over here is that if I is greater than start, or else we will return 1. So if we did not move at all, so for example if there were no digits, we will return 1. So this will implicitly handle the 1 in formula. So for example we have H2O, right? Now O has no number after it, so it consumes one oxygen, and that's where this if statement is important. Now the second is the parse name function. So an element is always one uppercase letter followed by 0 or one more lowercase letter. So we will start by unconditionally taking the first character because we already know that it's uppercase because of how we call it. Then we greedily grab any lowercase that follows it. So for example, if there is, mg over here like this, if there is mg, so it will be parsed as a single element rather than m and then g, because mg is one element, magnesium. Now this is our main loop. So we look at the current character and then the branch it is at. Then we start with the open parenthesis. So we step past this open parenthesis and we push a brand new empty counter. Now everything we parse from now until we find its matching closed parenthesis, it will accumulate into this new top of stack counter, which will be isolated from the one below. Now this is the closed parenthesis. So we step past this closed parenthesis and then we read the multiplier that follows it, which will be 1 if there is no number because of this. And then we will pop the top counter. Now that's a completed group. And then we merge it down into the counter that is now on top, and we multiply every count by this mult. So for example, I've given an example over here. If it's SO3 parenthesis 2, then it will pop S1O3, and then it will add S2 because it's multiplying 1 with the 2 and then 3 with the 2. So it will add S2O6 to the level below. And then we have our third case, which is our else statement. So anything else, right? So if it's not a parenthesis, it must be the start of an element name, so which means an uppercase letter, and we parse the name, then we parse the number right after it. Again, it will be default to 1 if there is no number, and then we add it to the current top counter. And this last step is how we build the answer. So after the loop, all the groups have collapsed back, and R and stack 0, this one, will hold every atom's total count. Stack of 0 will hold every atom's total count. Now, if you've read the problem description, it does require the output to be sorted alphabetically by element name. So we are iterating over this sorted result. And then for each element, we append its name, and we append the count only if it's greater than 1. So for example, if there's O2, O2 is written with the 2, but H is written with H and not like H1. So we are only appending if it's greater than 1. And then we just join everything together. And that's the end of it.